Hello all. Today we'll see one CPU scheduling algorithm or first CPU scheduling algorithm rather, that is FCFS scheduling. What is FCFS? FCFS is first come first serve scheduling algorithm. There are several algorithms in CPU scheduling, but this is the first one. Okay, so what is FCFS? FCFS is a first come first serve scheduling algorithm. Simply schedules the job according to the arrival time. Means what? Whichever job is come first will serve first on CPU. Means from ready queue to running queue, which job will come first, which will come first, it will serve first, which will come second, it will come second. So it is just follow the first in first out kind of thing of a queue, that is your data structure, first in first out. So whichever job will come first or whichever process will come first, it will execute on CPU first and then the second one. So the lesser arrival time of the job, the sooner will the job get the CPU. Okay. And the most important thing, the FCFS scheduling algorithm is non-preemptive. Now, what do you mean by non-preemptive? Non-preemptive means what? When any process gets the CPU, the operating system cannot remove that process from the CPU, means from the running state. If that process get over or terminated, or if that process requires some kind of input output, in that case only that process will uh, remove from the CPU. Otherwise that process will complete its work and then only the second process will come. That is a non-preemptive thing. So FCFS scheduling algorithm is non-preemptive algorithm. Now just try to understand. As I told you, it's a queue. It has a tail and it has a head. Now, when a process enter in a ready queue, the PCB is linked into the tail of the queue. Means new process will join at the end of the queue. And when the CPU is free, the allocated process at the head of the queue, and all the running process then removed from the queue. So whenever the processor will be free, the one process from the head side will go in a running state in a CPU, and whenever new process will come in a ready queue, it will be at the end of the queue. So that is at the tail part of the queue. And if the CPU is free, then the new process will allocate the CPU from the head side. And FCFS scheduling algorithm may cause a problem of starvation if burst time of the first process is the longest among all the jobs. What do you mean by that? Say for example, first process or the process that is going inside the running in a running state, if the CPU burst time is more, then what happen? Rest of the process has to be wait or has to wait for that process to complete. So total average processing time of that whole queue will be more. We'll see that kind of example also later on, but just try to explain you that is a starvation. When you have a long burst time process come at the beginning of the process queue, then it will create a problem. Why? Because rest of the process has to wait to complete that particular process. Okay, so it's a simple, easy NFCFS, and as I told you, it is non-preemptive and it has a starvation problem, and it's a poor performance. Why? Because average waiting time will be higher compared to other algorithms that we have in a CPU scheduling. So these are the simple advantages and disadvantages of that. Okay, now convoy effect, I already explained you convoy effect, that is a starvation, but I'll just explain you. FCFS may suffer from a convoy effect because if the convoy is going, then rest of the traffic has to wait same way. If the higher priority process is coming in the system, then rest of the process has to wait for their turn. So the total average processing time will be higher compared to other scheduling algorithms. Now we'll see few example of that. Say for example, there are four processes P1, P2, P3 and P4, and the burst time is given 17, 5, 1 and 5. Now you can see in process 1 we have a 17 burst time. You can see any unit, millisecond or second, but we'll take a 17 units as a time, and it is higher compared to other. So for that, if you want to check this, then you have to create a Gantt chart. Now what do you mean by Gantt chart? Gantt chart is a simple a pictorial presentation of graphical presentation of your process and its burst time. So you can see every process start from 0. Then first process will second 17 minutes. After that only the second process will go in a running state. So running state, after first process that completed on the 17 unit, the second process P2 will go and it will take 5 unit of time. So 17 plus 5, that will be 22 minutes. Then the P3 will go and it will take 1 unit of time. So 22 plus 1, that is 23, and process 4 will go. We use 5 burst time. So 23 plus 5, that is 28. So total time to complete this 4 processes 28 minutes, 28 units, you can say. So waiting time will be what? For P1 the waiting time is 0 because it is a first process. Second process the waiting time is 17 units of time. Third process the waiting time is 22 units of time, and fourth process, so 22 units of time, and fourth process 23 units of time. So average waiting time will be 0 plus 17 plus 22 plus 23 divided by 4 because there are 4 processes. So average time will be 15.5. Now this is a process schedule. Right now is P1, P2, P3 and P4. But if you change that to P3, P2, P4, P1, you can see over here P3 has less 1, P2 5, P4 5 and P1 17. So if you go that way, then the process 3 will come first. In that case it will take only 1 unit of time. P2 will take 5, so 1 plus 5 is 6. P4 also will take 5, so 6 plus 5 is 11, and P1 this last, that is 17, so 11 plus 17 is 28. So the total time to complete the whole 4 process will remain same, but here you can see waiting time is different. Now what is the waiting time? So waiting time is something like this. For P3 it's a 0, P2 it's a 1, P4 it's a 6, and P1 that is 11. Right? And if you take an average time of that, then it will be 4.5. And in previous example you can say the average waiting time is 15.5, but over here the average time is 4.5. So you can say considerable reduction in a total average waiting time. Okay, now we'll see second example. The same kind of example with some other things that we have added over here. So process 1, P1, there are 4 processes, P1, P2, P3 and P4, and burst time is given 7, 5, 1 and 5. So first we have to create a Gantt chart. Now Gantt chart you can see P1 it is 7, right? P2 that is it will burst time is 5. So first process will start from 0, second process will start at 5 point at the 7 position because first time is 7 units. So P2 and P3 that is 1, so 7 plus 1 7 plus 5 that is 12. Then P3 is 1, to 12 plus 1 is 13, and last one is P4 that is 13 plus 5 that is 18. So P1 the burst time is 7, P2 that is burst time is 5. So you can say response time. Now what do you mean by response time? Response time means what? When that process starts its work in a running state. So P1 it will start 0, P2 it will start from 7, P3 it will start from 7 plus 5 that is 12, P4 it will start from 13 because 12 plus 1 is 13. Correct. So that way the response time. Now waiting time means what? Waiting time is, that is very simple. What amount of time it has to wait before going into the running state. In that case, first process it will take just a 0 second. Correct. Because it's starting P2 it will take 7 unit of time. For the 7 unit of waiting, why? Because first process will take 7 minutes or 7 unit of time. Third process waiting time is 12 because first process will take 7 unit of time. Second process will take 5 units of time. So 7 plus 5 that is 12, and P4 will take 13 unit of time because 7 plus 5 plus 1 that is 30. Right. And what is the turnaround time? Turnaround time is completion time minus arrival time, or waiting time waiting time plus burst time. Now waiting time plus burst time, that is 7 plus 0 is 7, 7 plus 5 is 12 for P2, for P3 12 plus 1 that is 13, and for P4 13 plus 5 that is 18. So total time is also given and average time is also given. So there are certain questions they can ask, that is response time, waiting time, turnaround time, then one more thing is completion time that we'll see in the next example. So these are the some time that you have to perform for this kind of examples. This is another simple example, but in most of the time this kind of example will be there, right? So just try to understand this example here. Arrival time is also given and burst time is also given. So there are four processes, P1, P2, P3 and P4, and arrival time is given and burst time is given. So first of all, what do we have to create? We have to create the Gantt chart. So first P1 will come into running state. It will take 7 unit of burst time, so 7. Then P2 will come, it will take 5 unit of time, so 7 plus 5, that is 12. To completion of P2 it will take 12, that is 7 plus 5. Then P3 will come, it will take 1 burst time, and P4 will take 5 burst time. So that way you can create your Gantt chart very easily. But now we have to create a matrix, that is what you have to find out: response time, waiting time and turnaround time. Okay, so what is the response time? Response time is time at which the process get the CPU for the first time minus arrival time. Okay, so first process, when the CPU will take the first time, it will arrive at the first time, it is 0 point, so 0, right? And what is the arrival time? 0. The 0 minus 0 response time is 0. Now for 2, at what time your P2 process will come in the system, gets the CPU for the first time? That is at 7 point, at this point 7. Why? Because at 7 point this at 7 unit of time P1 will over, so at that time P2 will come. So 7 unit minus the arrival time, that is 1, so 7 minus 1 is 6. Same way, now the third process, how to find out this response time? Because it will take, say for example, first uh, process complete at 7 unit of time, second process will complete in a 5 unit of time, so 7 plus 5, that is 12. And what is the arrival time of P3? That is 2. So 12 minus 2, that is 10. 7 plus 5, that is 12. That is a starting when the first time the process 3 will get the CPU, and arrival time is 2. So 12 plus 12, so 12 minus 2 is 10. And same way for process 4, 7 plus 5 plus 1, that is 12 plus 1, 13. That is the first time it will get the CPU minus 4. So 13 minus 4 is what? 9. So that way you can find out the response time. Now waiting time. Waiting time is what? First process, obviously it will be 0. For second process, second process start at 6 time, right? Waiting time, that is 6 time, but arrival is 1. So first process will complete at 7 unit of time, correct? But the second process arrive at 1 unit of time. So 7 minus 1, that is 6. Okay. Now for third process, when it will arrive in the first time, that is, as I told you, 7 plus 5, that is 12 unit of time. So first time it arrived at a 12 unit, but first time it will get the CPU as 12 unit of time, but the arrival time is 2. So 12 minus 2 is what? 10. Sorry. Then for fourth, that is 13, that is 7 plus 5 plus 1, then 13, and 13 minus 4, because 13 is the first time it will get the CPU, and at fourth unit of time it arrived in the system. So 13 minus 4, that is 9. That way you can find out the waiting time. And you can see over here, in a non-preemptive algorithm, your response time and waiting time will remain same always. Always in a non-preemptive algorithm, your response time and waiting time will remain same. So now turnaround time, the formula is completion time, turnaround time, that is waiting time plus burst time. So waiting time is what? Waiting time is 0 and burst time is 7. So it will be 7, then 6 plus 5, that is 11, 10 plus 1, that is 11, 9 plus 5, that is 14. So that way you can find out total and you can find out the average. Okay, so that way you can find out this things, that is the response time, waiting time and turnaround time. Now we see the last example where there are one more thing we are going to add in this, that is a completion time. Now, so you can see process 1, 2, 3, 4, and 5. There are 5 processes. So first we need to create a Gantt chart. But here the arrival time is given. Now in previous example, the arrival time in a sequence, that is first, second, third, fourth, means 0, then this is 1, this is 2, and 4, right? So it is in sequence, so we don't have to worry about it. But over here, you can see arrival time there is 2, 0, 2, 3, and 4. So you can say there are 5 processes P1, P2, P3, P4, and P5, but we cannot directly use P1 or directly put P1 as first. Why? Because at 0th process, and as I told you, your process time will start from 0. Alright, okay. So at second time, second unit time, P1 is not there. So first, which one? The lesser the arrival time, that is 0. So first time P2 will come in a system. So P2, right? And what is the burst time? 1. So at a 1 burst time, it will get over, right? But now next process will come at second burst time. Time is arrival time is 2. You can see over here. Where? Here, right? So but this P2 is completed at once. So from 1 to 2 your system or your CPU is idle. So I will display that in a different color, because you can consider this as idle time for CPU, because in this time there is no process in the running state. I hope you understand this thing, because P2 the burst time is only 1 and second process will come at 2. So 1 to 2, 1 unit of time your CPU is remain idle. Okay, now but at 2 point of time, now next there are 2 processes. But here you have to follow the first come first serve. So P1 will come first, obviously, because the process the way it is given in a example, that you have to follow. The P1 is first displayed on your example, so P2 will come first, so it will take 2 burst time, 2, and then P3 will come for 3 unit of time. So that is 2 plus 2, that is 4 for second first one, and P3 that is 4 plus 3, that is 7. Now next the P4 will come at unit time 5. So 4 plus 5, that is 5. 7 plus 5, that is 12, and the P5 it will take 4 burst time. The 12 plus 4 is 16. So that way we can create this Gantt chart. I hope you understand this thing, why we have taken this idle time, because again try to understand. First P2 will come in the system, so it will start from 0, and it is a burst time is only 1, so 1, but next process will come at 2 unit of time. So 1 and 2, this portion it remain idle. Okay. Now first find out the completion time. Now what do you mean by completion time? When the process get completed. So P1 get completed at 4 unit of time. So 4 you can write down. P2 at 1. So you can write down 1. P3 at 7. So you can write down 7. P4 that is 12. Sorry, 12. So you can write down 12 over here. And P5 at is 16. So P5 is 16. So CT is your completion time. You can write down completion from your Gantt chart very easily. Now the turnaround time. Turnaround time means what? Completion time minus arrival time. So completion minus arrival. So 4 minus 2, that is 2. 1 minus 0, that is 1. 7 minus 2, that is 5. 12 minus 3 is 9. And 16 minus 4 is 12. Okay, now waiting time means what? Turnaround time minus burst time. So turnaround time minus burst time. 2 minus 2, that is 0. 1 minus 1, that is 0. 5 minus 3 is 2. 9 minus 5 is 4, and 12 minus 4 is 8. And response time, again, time at which the process gets the CPU for the first time minus arrival time. Time at the CPU first time at P2, sorry, P1, that is 2, and arrival time is 2. So 2 minus 2 is 0. For P1, the arrival time is what? 2, and sorry, first time it gets the CPU at 2, and this arrival time is 2, so you can write down 0 over here, right? P3 arrival time is 4, and sorry, first time it gets the CPU, that is 4, and arrival time is what? 2. So 4 minus 2 is 2. Now here P4 7, 7 minus 3 is 4, and here 12, and 12 minus 4 is 8. So as I told you, waiting time and response time will remain same in all non-preemptive algorithms. So you can see over here both things are same. Here you can find out average waiting time, average turnaround time, total waiting time, total response time, total completion time, everything, an average of all this thing. If you want, you can find out very easy. So that is all about your uh, FCFS algorithm. Thank you.